Okay, today on lesson 8 we're doing percent error problems. So before we start, there are some things I want you to write down up at the top. There's some formulas you're going to need to know. So if you are asked to find the absolute error your formula is the absolute value of a minus x. If you are asked to find the percent error, your formula is the absolute value of a minus x over the absolute value of x times 100. Now at this point you might be asking, what is a and what is x? So we need to identify those. So x is the exact value of something, of a quantity, and a is the approximate value. So you want to make sure you write those down before you continue on. So if you don't have them written down yet, go ahead and pause it until you have them written down. So here we're going to look at how to find the percent error. So how right is wrong. So for Taylor's first measurement, we solved and we got 1/4. So the top is the absolute value of 1/4. The bottom is the absolute value of 15. Remember our formula from the other side, times 100. So we solve absolute values first. So 1/4 divided by 15 times 100. You plug that in the calculator, and when you do that, you get 1 2/3%. Or you could, if you have a decimal, 1 6/10 repetin percent. Now we're doing the same thing with Connor's. From his first measurements, we've already done the subtraction on the other side. And so we have absolute value of 1/2 over the absolute value of 15 times 100. So 1/2 divided by 15 times 100. We plug that into our calculator, 3 1/3%, or 3 3/10%. Okay, and then for the next one, it says find Jordan's second measurement, her percent error. And so when we did that, we had absolute value of 1/4 over the absolute value of 15 times 100. We calculated that same computation up at the top. Oops, it was negative 1/4 there. So, but when we take absolute value 1/4 divided by 15 times 100, and so we get 1 2/3%. or 1 6/10 repetin percent. And so you can see from a comparison standpoint, knowing the percent error, that Jordan and Taylor made the same percentage of error, whereas Connor's measurement error was a little bit bigger. He was a little further off. On D, it says, what is the purpose of finding the percent error? It tells you how big your error is compared to the true value. And the reason that's important, when we find the percent of error versus the actual error, if I'm finding actual error and somebody is off by 1 centimeter, that that may not sound like much because that's the actual error. But when I take it and look at percentage, if somebody is measuring the length of a marathon race and they're off by 1 centimeter, that's not a big deal. They're not off by much. But if somebody is performing heart surgery and they make their incision off by 1 centimeter, that's going to be a big deal, because that 1 centimeter could make a huge difference in how the person reacts to the surgery and how well the surgeon can do their job. So that percentage is really important as compared to what the actual number value is. So 1 centimeter doesn't sound like a lot. And if it's a marathon, 1 centimeter isn't a lot. But if I'm doing heart surgery, 1 centimeter is a lot. Okay, so it asks us here in these different situations to calculate the percent of error. And then it says leave your final answer in fraction form if necessary. So if something does not come out to be a whole number, then you're going to want to write your remainder as a fraction. So a real estate agent expected 18 people to show up for an open house, but 25 actually attended. So we have two numbers, and we got to decide which one of those is our A and which one's our X. So A belongs to the 18 people. That was their approximation. And 25 is our X, because that's the actual number that attended. So when I plug it into my formula, I have 18, the absolute value of 18 minus 25 over the absolute value of 25 times 100. So I'm going to subtract 18 minus 25, and I get negative 7. So I have the absolute value of negative 7 over the absolute value of 25 times 100. So now I take my absolute values, 7/25 times 100, plug that in my calculator, and when I do that, I get 28%. So the real estate's error was 28%. She was off by 28% in estimating how many people would be there. Okay, in our next example, in science class, Miss Moore's students were directed to weigh a 300-gram mass on a balance scale. Tina weighed the object and reported that it was 328 grams. So the 300-gram mass, that's the actual object, so that's my X. And the student Tina, that was her approximation. That's what she came up with. So absolute value of 328 minus 300 over the absolute value of 300 times 100. So after I subtract, I have the absolute value of 28 over the absolute value of 300 times 100. So I have 28 300ths times 100. And when I do that, I have a 9 1/3% error. So she was off by 9 1/3%. Darwin's coach recorded that he had bowled 250 points out of 300 in a bowling tournament. However, the official scoreboard showed that Darwin actually bowled 250 points out of 300. So we don't need the 300s for what we're doing. The 225 points was the actual amount, and the 250 was the coach's approximation. So 250 minus 225, absolute value of that subtraction over the absolute value of 225. Take that times 100. So I subtract and I get 25. So the absolute value of 25 over the absolute value of 225 times 100. So 25 225ths times 100. When you multiply that, the coach's error was 11 1/9% is what he was off of. Okay, on example 3, estimating percent error. So estimating means we're not going to have exact numbers. It says attendance at the music festival was counted several times. All the counts were between 573 and 589. If the actual attendance is somewhere between those two numbers, inclusive, what is the most the percent error could be? And explain your answer. So the difference between those two numbers is 16. So the greatest spread, amount of error, 16. So the absolute value of that. And we would use the 573, the lower amount, as our denominator, as our actual for that, for finding the percent, times 100. So then 16 573s times 100, and you get 2 8/10%. And on that, that's a rounded value. That means the error someone made is 2 8/10% or less in reporting their number. On this problem set, do the evens.